So today let's talk about the finite element method, FEM. So before talking about the finite element method, we need to understand that there are two main types of methods to solve problems in the civil engineering aspect. So these are the numerical method and the analytical method. So first of all, the analytical methods, and there are a lot of analytical methods that we use to solve structural mechanics problems, whether it is to calculate the deflection of a beam or maybe to calculate the stresses and things like that. But we often encounter some problems, typically because sometimes the load combinations, the materials or the geometry of the structure is too complicated to solve. This is where FEM comes in hand. So how can I say, the main idea of FEM is to divide a large complicated structure, a body, into a, how to say, smaller and simpler parts called the finite elements. For example, last 2 weeks ago, in the second day of the class, the professor gave us an object, irregular shaped object, and a graph paper and instruct us to estimate the area of that object. So for our group, we just simply drew the shape of the object on the graph paper, and then we can just measure the area of a square in the object. And so we can just simply count the how many numbers of squares are in that object, and then we can just estimate the area of the whole object. So that is the main concept of finite element method. And okay, another example of like enforcing equilibrium over a complex two-dimensional structure is complicated, right? But what if it is three-dimensional? It will even get more complicated, for a three-dimensional body. So FEM approach this kinds of problem by splitting the body into a number of smaller elements that are connected at the nodes, and this whole process is called discretization, and the collection of all the nodes and elements is called the mesh. So why is discretization important? Discretization is useful because the equilibrium require now only it only needs to be satisfied over a finite element of discrete elements instead of the whole continuous body. So instead of solving the difficult the whole problem directly, FEM breaks it into a manageable smaller parts, and that can be solved more easily. So from this course, I expect to gain a clear understanding of the fundamental theory of the finite element method. I expect to be able to solve some one-dimensional or maybe even two-dimensional problems and apply the finite element methods into my civil engineering problems. And I also want to learn the software like SAP 2000 and Abacus that the professors will surely teach us in this course. And I believe that the learning experience from this course will surely benefit me for my future career. And this is all for this video, and thank you so much.